Welcome to the second segment on logic. Today we're going to go into a little bit more about what form mathematicians use to make these logical arguments. The basic form is really an if-then statement. So if-then statements are a lot what they sound like. They take whether it's a simple statement or a more complex statement and turn them into an if-then statement, which looks a lot like this. If it is Halloween, then it is scary. What I'm doing is trying to make one statement dependent on the other. So if it is night, then it is black. So before I can conclude it's black, I have to know that it's night. If it is a cat, then it is night. They don't necessarily have to make sense, but what they do have to do is one has to follow the other. So in a more complex form, if Halloween is fun, then I'm having a good time. Okay, so really all we're doing is taking a statement and putting into the if-then format. We can do this with almost anything that we say. So we can turn a sentence into an if-then statement by taking their logic and putting it out in order. So my mom has red hair can change into, if she is my mom, then she has red hair. Therefore, if the woman is my mom, she has red hair, which is the same thing as saying my mom has red hair. Or I walk to the store every Sunday can be changed into, if it is Sunday, then I walk to the store. Now you have to be careful, because if I had said, if I walk to the store, then it is Sunday, I'm actually changing the meaning of that beginning sentence. I walk to the store every Sunday means that on Sunday, I walk to the store. It doesn't necessarily mean that I only walk to the store on Sunday, which is what that second if-then statement is saying. If I walk to the store, then it has to be Sunday. Okay, so be careful with your meaning in that way. So let's look at something the mathematicians call notation or shorthand. A lot of times we say, if A, then B, where we make A and B pretty much any sentence. So we use it this way, which reads, if A, then B, or this way, which also reads, if A, then B. Whether you're using this symbol here or this symbol here, they mean the same thing. If I have A, then I have B. So if A, then B. Now, this is more of an abstract thought to what we were just doing, but it works with all things. So if I take two statements where I say my A statement is I like ice cream and my B statement is I like sweets, then all I do is replace the A and B with those statements. So if A, then B. If I like ice cream, then I like sweets. The nice thing about labeling them A and B is we can switch them around really quickly. So I can say, well, if B, then A, which just means if I like sweets, then I like ice cream. So when we see this in math, all we're really saying is that A and B make some type of statements, and we're saying one follows the other. It allows us for a short notation. So what you guys are going to do next is try a little bit of this out for yourself. Make a couple of if-then statements. See you next time.